Now, today we are going to start with a new topic, indeterminate forms. Now, what is the indeterminate forms? In mathematics, we are going to discuss about limit. Now, in limit, you have learned simple limit, but in today's lecture, we are going to discuss the indeterminate form. What is the indeterminate form? Where the limit is not exist, that means it is exists but it is of the form either 0 by 0 or infinite by infinite. In such a case, you cannot say what is the exact value of your limit. So such type of example is called the indeterminate form. Now in today's session we are going to check out Lapitals rule and 0 by 0 form. First, we have already discussed that what is the indeterminate form. The form like 0 by 0 or infinity by infinity is called a indeterminate form. Now, what is the basic concept? Suppose fx and gx are two functions written in a form of limit x tends to a fx upon gx. Then by properties of limit we can separate the limit in numerator and denominator, provided that that denominator has a limit non-zero. Now, suppose that the denominator has a limit 0, then in that case we are concerned with limit of numerator, that means limit of fx. Suppose limit of fx is also 0. If it is non-zero, then you will have infinite limit. That means something non-zero upon 0 that will have an infinite value. That means you have a limit but it has an infinite value. But here suppose fx is the limit 0 as x tends to a. So in that case, your value, you don't know what is the exact value of fx upon gx, correct? So in this kind of form is called indeterminate form. Now whenever you have any indeterminate form, then it is, you have already done some of the examples such as a sin x upon x where x tends to 0, or cos x minus 1 upon x square. This both are indeterminate form. Same manner x tends to 1, sin x minus 1 upon x minus 1 is also the indeterminate form, and these all are the 0 by 0 form. There are some another forms which are also the indeterminate forms, such as infinity by infinity, 0 into infinity, infinity minus infinity, 0 raised to 0, infinity raised to 0, and 1 raised to infinity. See, what we are going to do, basically we are dividing in this 7 indeterminate forms into two parts. First part contains 0 by 0 and infinity by infinity form, where the Lapitals rule is directly applicable, and the remaining one you have to reduce the remaining terms in a form of 0 by 0 and infinity by infinity. Now, what is the Lapitals rule? Or now Lapitals rule for 0 by 0 form. Suppose fx and gx are two functions and they have a Taylor series expansion at a point x is equal to a, and if limit of fx is 0 where x tends to a and limit of gx is also 0, that means f of a has a value 0, g of a has a value 0, that means your limit is of the form 0 by 0. Then in that case, limit x tends to a fx upon gx, that will be a limit x tends to a f dash upon g dash, correct? Now g dash a has a value non-zero, then you will have this limit, okay? So what we are going to do, we are going to use the Taylor series expansion of a function fx and gx. Now suppose fx has the Taylor series expansion fa plus x minus a into f dash of a plus x minus a whole square by 2 factorial double dash of a, and so on, so on, so on, divided by ga plus x minus a into g dash a plus x minus a whole square into g whole square by 2 factorial into g double dash of a, and so on, okay? Now basically f of a and g of a has a value 0. So first two terms in numerator, first term in numerator and denominator are going to be 0. So the remaining limit you will have limit x tends to a x minus a into f dash of a plus x minus a whole square by 2 factorial f double dash of a plus dot dot dot. Same manner in denominator you will have x minus a g dash of a plus x minus a whole square by 2 factorial g double dash of a and so on. Now we are going to common out x minus a from numerator and denominator. So x minus a will be cancelled from numerator and denominator, and you will have limit x tends to a f dash of a plus x minus a upon 2 factorial f double dash of a plus dot 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 divided by g dash of a plus x minus a divided by 2 factorial g double dash of a and so on, so on, so on. Now see, here limit x tends to a, and since we have already known that g dash has a one value non-zero, so if you are applying limit as x tends to a, then the except the first term in numerator and denominator, all terms are going to be 0. So that will give you f dash upon g dash a, f dash a upon g dash a. So this is your statement of theorem. If you have limit f dash upon g dash where x tends to a, then it will be same as limit f dash upon g dash x where x tends to a. Okay. Now, what are the working rules for 0 by 0 form? Suppose capital L is equal to limit x tends to a fx divided by gx. So we are going to apply the Lapitals rule. If it is 0 by 0 form, then that will give you limit x tends to a f dash x upon g dash x. Again, if it is still 0 by 0, then again we are going to apply the Lapitals rule. That will give you limit f double dash x upon g double dash x. If still it is 0 by 0, then you have to continue. Again you will have limit x tends to a f triple dash x upon g triple dash x. And you have to continue in this manner until the 0 by 0 form is going to be breakdown. Suppose now either of the value, either numerator or denominator has a value non-zero, then we are going to stop here. Okay. So this is the basic concept for working rule. Now here we are going to write down some standard limit, and we are going to use this directly whenever we needed it, because see, basically these limits are also obtained from the indeterminate forms. Okay. So first limit is sin x upon x where x tends to 0 has a value 1, that you are already aware of. Same manner tan x upon x where x tends to 0 has a value 1. Same manner limit x tends to 0 a raised to x minus 1 upon x has a value log a, and e raised to x minus 1 upon x has a value log e, that means it has a value 1. Limit x tends to 0 1 plus x raised to 1 upon x has a value e, and same manner limit 1 plus 1 upon x raised to x also has a value e. Okay. These are some standard limits. Whenever it is needed to put the values directly, in that case we are going to use them directly, otherwise we are going to apply the Lapitals rule. Okay, please remember this thing. And basically this all limits are obtained by indeterminate forms. Now, so if suppose you have any function and the quotient rule is not applicable whenever the 0 by 0 form is there, so in that case we are going to use such type of standard limits. Also, suppose you have form limit hx into fx upon gx, and hx is one of the standard form of the limit which we have written here. Then we are going to separate the limits, and since you are already aware of what is the limit of hx, put it, and the remaining function you will have fx by gx. Now it is 0 by 0 form, then you can apply the Lapitals rule, because the first limit is going to be constant out. Same manner, some of the basic concept we have to consider, such as suppose you have given limit x tends to 0 log x, that means you have only right hand side limit, left hand side limit is not there. Please remember, because log is defined for only x greater than 0, that means we are going to put the right hand side limit if you have written x tends to 0. Okay. Now we are going with examples. Now first example, limit x tends to 0 e raised to x plus e raised to minus x square minus 2 divided by sin square x minus x square. Now see, if you are going to put the values, then it is a 0 by 0 form. E raised to 0 1, e raised to 0 1, so 1 plus 1 2, minus 0 minus 2, so 2 minus 2 will be 0. Same manner sin 0 has a value 0, x square also has a value 0, so you will have 0 by 0 form. Now it is 0 by 0 form, so applying Lapitals rule, that will give you, that means you have to take a differentiation of numerator in numerator and differentiation of denominator in denominator. So numerator has a derivative e raised to x, has a derivative e raised to x, e raised to minus x has a derivative minus e raised to minus x, x square has a derivative minus 2x, divided by sin square x has a derivative 2 sin x into cos x, that means it is nothing but sin 2x, and x square again has a derivative 2x. Now if you are going to put the limit, then e raised to 0 is 1, minus e raised to 0 is 1, so 1 minus 1 0, minus 0, so numerator term is still 0. Same manner denominator, sin 0 has a value 0 and x has a value 0, so denominator is also 0. So it is still 0 by 0 form. So again you have to apply the Lapitals rule. So if you are applying the Lapitals rule again, then you will have e raised to x plus e raised to minus x minus 2, divided by sin 2x as a derivative 2 cos 2x minus 2. See, here we are not applying the quotient rule. Please remember, the derivative of numerator will remain in numerator and derivative of denominator will remain in denominator. That they are treated as a separate two functions. Now again, if you are going to put the limit in the last term, then e raised to 0 has a value 1. E raised to 0 also has a value 1, so 1 plus 1 2 minus 2, that means numerator is still 0. Same manner denominator cos 0 has a value 1, so 2 into 1 is 2 minus 2, so again denominator also has a value 0. So again we are going to apply the Lapitals rule, and that will give you e raised to x minus e raised to minus x divided by minus 4 times, because cos has a derivative minus sine, into 2, that will give you minus 4 sine 2x. If you are going to apply limit, then still it is 0 by 0, because 1 minus 1 divided by 0, that means 0 by 0 form is there. So now again applying the Lapitals rule, so you will have e raised to x plus e raised to minus x divided by minus 8 cos 2x, and now the numerator part has a value non-zero, same manner denominator also has a value non-zero, so we are going to directly apply the limit. That will give 1 plus 1 upon minus 8 into 1, that means 2 by minus 8, that will be minus 1 by 4, correct? So same manner we are going to check another example. Limit x tends to 1, x raised to x minus x divided by x minus 1 minus log x. Now see here, what we are going to do, we are going to suppose capital L is equal to x raised to x minus x divided by x minus 1 minus log x, where limit x tends to 1. This is 0 by 0 form, check out, because 1 raised to 1 minus 1 divided by 1 minus 1 0 and log 1 is 0, so 0 by 0 form is there. Now applying the Lapitals rule, so derivative of numerator in numerator, denominator in denominator, that will give you x raised to x as a derivative x raised to x into 1 plus log x minus x as a derivative 1 divided by x as a derivative 1, 1 has a derivative 0, log has a derivative 1 upon x. If you are putting the limit, then you will again have a 1 minus 1 divided by 1 minus 1, that means it is 0 by 0 form. So continuing Lapitals rule, that will give you x raised to x as it is, and derivative of bracket, that will be a 1 upon x, because 1 has a derivative 0, log has a 1 upon x, plus 1 plus log x as it is, derivative of x raised to x will be x raised to x into 1 plus log x, divided by 1 as a derivative 0 and 1 upon x as a derivative minus 1 upon x square. Now see, this is not, denominator is obviously non-zero, so we are going to put the limit, and if you are going to put the limit, then that will give you 1 into 1 plus 1 plus 0 into 1 into 1 plus 0 divided by 1. That will give you the answer 2 divided by 1, that means it is 2. So same manner, here we are going to take another example. Limit x tends to 0, tan square upon x square divided by x square into tan square x. Now what we have is, basically in a denominator you have a two function x square and tan square. So what we are going to do, this is 0 by 0 form, but we are going to simplify it. We are going to multiply and divide in denominator by x square. So you will have 10 square upon x square in denominator, but 10x upon x has a limit 1. So we are going to separate that function like hx we have defined, and then we are going to write down its limit 1. So the remaining part you will have is limit x tends to 0, 10 square x minus x square divided by x raised to 4. Now this is a 0 by 0 form. So applying the Lapitals rule, that will give you, in the numerator you will have 2 10x into sec square x minus 2x divided by 4x cube, because x raised to 4 is a derivative 4x cube. Still this is 0 by 0, again applying the Lapitals rule, that will give you 2 10x into 2 10x 2 sec x 10x plus sec square x into 2 sec square x minus 2 divided by 12x square. Simplifying the numerator, that will give you 4 sec square 10 square plus 2 sec raised to 4 minus 2 divided by 12x square. Still it is 0 by 0. So again applying the Lapitals rule, that will give you 4 sec square into 2 10x sec square x plus 4 10 square into 2 sec x into sec x 10x plus 2 into 4 sec cube x into sec x 10x. And if you are simplifying the numerator, then that will be a 2 sec raised to 4 10x plus 8 sec square into 10 cube plus 8 sec raised to 4 into 10x. And the denominator has a derivative 24x. So now separate the limits, because 10x upon x has a value 1. So that will give you 10x by x has a value 1. So first part has a value 16 upon 24 and second part has a value 0. So first limit is 16 upon 24, and if you are going to simplify it, then it has a value 2 by 3. So now we are going to check another example using indeterminate forms. We are going to find the limit. That means we are going to, limit is already given, limit has a value 2, and using that we are going to find the values of a, b, c. Here you have given that limit x tends to 0, a e raised to x minus b cos x plus c e raised to minus x divided by x sin x has a limit 2. That means limit exists, that is given. So limit exists, that's why it has a value 2. And we have to find for what values of a, b and c this limit has a value 2. So what we are going to do, we are going to start with capital L is equal to limit a e raised to x minus b cos x plus c e raised to minus x divided by x sin x. Again in denominator you have sign in a multiplication. So what we are going to do, we are going to multiply and divide by x in denominator. That will give you x square into sin x by x. And sin x upon x has a limit 1. So the remaining term we have is a e raised to x minus b cos x plus c e raised to minus x upon x square. Now check out. See, this must be 0 by 0 form, because denominator is already 0. So if and only if the numerator is going to be 0, then only we have a limit. So if you are going to put the limit that in numerator part, then you will have a minus b plus c. Then that term must be a 0, then only the limit exists, correct? So if you have to apply the Lapitals rule, then numerator also must be a 0. That means a minus b plus c has a value 0. Now applying the Lapitals rule in first equation, so again you will have a e raised to x plus b sin x minus c e raised to minus x divided by 2x. Again denominator is 0, so numerator must be 0. So applying limit, that will give you a minus c is equal to 0. So this is equation number 4. Now same manner apply Lapitals rule to equation number 3, and that will give you L is equal to limit x tends to 0, a e raised to x plus b cos x plus c e raised to minus x divided by 2. Now see, here denominator is now already non-zero. So you will have a limit, and capital L has a value 2, that is already given in a question. So L is replaced by 2, and applying limit to the right hand side, that will give you a plus 2 is equal to a plus b plus c divided by 2. and that will give a plus b plus c is equal to 4. So now you have equation 2, 4 and 5. Solve them and that will give you the values of a, b and c. So a has a value 2, b has a value, a has a value 1, b has a value 2 and c has a value 1. So these are some practice example that you have to do yourself, and if you have any query or any doubt regarding this topic, then please feel free to contact me. Thank you.